everybody, and in this video we will talk about the architecture of system on chip and many other thing here. So let's start. First of all, SOC stand for system on chip. It is a small integrated chip that contain all the required component and circuit of a particular system. The component of this system on chip include CPU, GPU, memory, input output device, etc. System on chip is used to in the various devices such as a smartphone, internet of the things applications, tablets, and embedded system application. In this video we are going to see the architecture and architectural feature of system option. System architecture of system option. The following diagram shows the architecture of system option. Multimedia encoder decoder, direct memory access, CPU, DSP, network interface card, audio, USB, video, and storage and memory. The basic architecture of system on chip is shown in the above figure. You can see here the basic architecture of the system on chip. For the multimedia encoder, direct memory access, CPU, DSP, network interface card, audio, USB, video, storage, memory. Okay, so this is the basic architecture of some system on chip. This is known as for the including processor, DSP, memory, network interface card, CPU, multimedia encoder, decoder, DMA, etc. Processor, it is the heart of the system on chip. Usually system on chip contain at least one or more than one processor. It can be microcontroller, microprocessor, or DSP. Most of the time DSP is used in every system on chip as a processor. DSP stands for the digital signal processor. It's included on the system on chip to perform single signal processing operation such as data collection, data processing, etc. It is also used to propose the decoding the images. Memory is used on the system on chip for the purpose of storage. It may be volatile and non-volatile memory. Volatile memory include RAM. There are the two type of the RAM, SRMA and another DRMA. The non-volatile memory include ROM. Encoder and decoder used for the purpose of the interpreting information and converting it into code. Network interface card. The system on chip has an internal interface or bus or network to connect all the individual blocks. Basically, the network interface card provides connection of the network to the system. GPU stands for the graphical processing unit. It is used to system on chip to visualize the surface interface. Graphical processing unit is especially designed to the speed of the operations related to image circulation. The basic block of the graphical processing unit are the bus interface, power management unit, video processing unit, graphic memory controller, display interface, etc. Peripheral device, externally connected device interface such as USB, HDMI, Wi-Fi, and Bluetooth are included in the peripheral device. This device is used as a system on chip to perform various operations. UART, Universal Area Receiver Transmitter, is included in system on chip, which is used to transmit and receive serial data. Voltage regulator, oscillator, clock, and ADC-DAC are also part of system on chip. Now let us see the some advantage and disadvantage of system on chip. The advantage of the system on chip: it is small in size and include many feature and function. It consumes low power. System on chip is flexible in terms of size and power factor. It is built on the single chip, so it is cost effective. It's produced in the large quantity. What are the disadvantage of system on chip? The time consuming designing process. Usually a designing process system on chip takes 6 and 12 months. A disadvantage of system on chip: time consuming designing process usually disadvantage of this system on chip: time consuming designing process. Usually a designing process system on chip takes 6 or 12 months. If any component of the system on chip is not functioning properly, then it cannot be replaced. In that case, an entire system on chip has to be replaced. Visibility of system on chip is limited. Uses of system on chip: used in smartphones, smartwatches, tablets, and computers. Internet of Things applications such as home automation, embedded system application, especially where the microcontroller is used. Coprocessor architecture, working types and its application. In a microprocessor chip, new circuitry is added as achieve special task and also operation on the number of the offload the CPU core work so that the CPU can function very fast. A supplementary processor like a compo processor coprocessor is mainly used in the computer to achieve the special task like a graphical display processing and wide arithmetic calculation. This processor is designed to perform such tasks very efficiently as compared to the CPU. Thus, overall computer speed can increase. We know that in the architecture working and application. So, what is the coprocessor? A processor which work with the main processor of a computer like the CPU side by side is known as a coprocessor. This processor is also known as a supplementary computer process. By using this processor, some difficult mathematical calculation can be performed like graphical display on the screen, signal processing, string processing, floating point arithmetic, input output interfacing, etc. Coprocessor architectures. You can see this example of the coprocessor image. So understanding for the something better. And the coprocessor architecture, the coprocessor like 8087 architecture is shown below. Generally the coprocessor work with the microprocessors parallelly. This coprocessor was developed by Intel and used with the 16-bit 8086 family microprocessor. When the processor function in combined with the microprocessor, the calculation portion is simply handled by the processor, and this allows the CPU to utilize the resources to execute various other activities. Architecture of the 8087 coprocessor. This architecture includes two main units like control unit and numeric execution unit, which is also known as NU. If you see this image, you see that control unit, control word, status word, data buffer, NU instruction, microcode control unit. And you can see the numeric execution unit, exponent bus, exponent modules, interface, fraction bus, programmable shifter, the arithmetic module, temporary register and register state. So what is 8087 coprocessor architecture? In the control unit there are the various units like data buffer, control and status word register, shared operator, QK, exception pointer and addressing and bus tracking unit. The numeric execution unit mainly include the microcode unit, control unit, register district, programmable shifter, temporary register, arithmetic module, exponent module and shared operand QT. The control unit in the micro coprocessor is the control the instruction execution for which the numeric execution unit is responsible, mostly the microcode control unit. The numeric execution unit contains the numeric instruction from the coprocessor control unit. This coprocessor has a complete 8 register of the 8-bit and each of these utilized to the LIFO. This take the operand over which is the coprocessor instruction will occur exist in the register stack. The existing stack is pointing through 3-bit stack pointer which holds the binary value which range from 00011 in order to show the 8 stack register. It's work with the circular stack bit to LIFO mode. But once the reset action occurs, the pointer can be initialized by binary value 000. The numeric data 3 classification on which the coprocessor function are packet, decimal number, real number and binary integers. The binary integers are the 3 types: 16-bit word integer, 32-bit shorter integer and 64-bit long integer. The 80-bit BCD format signify the packet decimal number, while real number 3 types 32-bit short real, 64-bit long real and 80-bit temporary real. For transferring the numeric data, coprocessor either 16-bit exponent bus or 64-bit the main data bus is utilized. The control word is written into the control register, and this task plays such a way that the coprocessor initially write the control code within the location of memory. After that, the coprocessor simply read the control word using the memory location and stores in the control register. Simply the status word read in such a way that the processor send the data in the status register toward the location of memory. Further, this coprocessor read the status register for the specific location of the memory. So this means processor and microprocessor communicate with each other by the main memory. Raspberry Pi pin die description. There are the 2 pins, 5B pins and 2 3B 3 pins, as well as the number of the ground pin 0B, which are the unconfigurable. The remaining pins are all general purpose 3B pin, meaning that output are set to 3.3 volt and input are tolerant to 3.3 volt. A GPIO, set up the high 3.3 volt or low OV component are adjust to the setting the output so high bill current to flow them, while setting the output to low or not. A ground put input output pin that is designated as the input will allow a signal to be the received by the Raspberry Pi. The threshold between a high and a low signal is around 1.8 volt, and a voltage between 1.8 volt and 3.3 volt will be read by the Raspberry Pi as a high. Anything lower than the 1.8 volt will be read as low. Do not allow an input voltage above 3.3 volt or else you will try your Pi. Here we will learn about the GPIO, general purpose input output connector in Raspberry Pi. GPIO pin out. One of the powerful feature of the Raspberry Pi is the row of GPIO, general purpose input output pins, and the GPIO pin out is an interactive reference to the GPIO pins following. If you see this diagram, then you saw as a 40 pin GPIO header which is found all of the current Raspberry Pi board. So here is a 3B3 power which is connected with a 5B power GPIO2, which is a 5B power connector GPI3, and the 4 GPIO general purpose input output 17, which is connected to the GPIO general purpose input output connector with the 80. So these are the diagrams you can understand. The voltage from the above diagrams, like this one we have discussed now, we can see that there are the two 5 volt pins and there is a 2 5 volt pin and 2 3BC pin on the board. It also has a several ground pin 0 volt. All these pins are unconfigurable output. The general purpose input output pins can be designed as the output pin. The pin set as an output pin can be set as 3B3 high or low. Inputs GPIO pins can be designed as an input pin. The pin set as an input pin can be read as a 3B3 high and 0B low. You can use internal pull up and pull down registers. You can see that diagram. Alternative function GPIO pin can be used with a variety of alternative functions. Among them, some are available on the all pins and other are specific pins. Central processing unit, they have the RAM, they have the ROM and system clock. System clock have the control unit and CPU clock, where RAM have the memory management unit, L2 and L3 cache, L1D cache, L1I cache, a register, B register, arithmetic and logical unit, instruction pointer, instruction register, accumulator. The computer central processing unit is the portion of the computer that retrieve and execute instruction. The CPU is essentially the brain of CAD system. It consists of an arithmetic and logic unit, a control unit and various registers. The CPU is often simply referred as the processor. To improve the performance of CPU, we have two options. Improve the hardware by introducing the faster circuit. Number second is arrange the hardware such that more than one operation can be performed at the same time. Since there is a limit on the speed of hardware and cost of faster circuit is quite high, we have adopted the second option, pipelining. Pipelining is the process of arrangement of hardware element of the CPU such that its overall performance is increased. Simultaneous execution of the more than one instruction take place in the pipeline processor. Let us see a real life example that work on the concept of the pipeline operation. Consider a water bottle packaging plant. Let there be the three stages that a bottle should pass through: the inserting the bottle, I, filling the bottle, F, and sealing the bottle, S. Let us consider these stages as stage 1, stage 2 and stage 3 respectively. Let each stage take the minute to complete its operation. Now is a non-pipeline operation. A bottle is first inserted in the plant. After 1 minute, it is moved to the stage 2 where water is filled. Now in stage 1, nothing is happening. Similarly, when the bottle moves to stage 3, both stage 1 and stage 2 are idle. But in the pipeline operation, when the bottle is in stage 2, another bottle can be loaded at stage 1. Similarly, when the bottle is in stage 3, there can be one bottle each in stage 1 and stage 2. So after each minute, P can get new bottle at the new stage 3. Hence the average time taken to manufacture one bottle is, without pipeline, 9 divided by 3 minute, 3 minute. With pipeline, 5 divided by 3 minute, 1.67 minute. So thus the pipeline operation increase the efficiency of a system. Designing of the basic pipeline. In a pipeline processor, a pipeline has a two ends, the input and the output end. Between these ends there are the multiple stage segments, such as the output of one stage is connected to the input of the next stage, and each stage perform a specific operation. Interface registers are used to hold the intermediate output between the two stages. These interface registers are also called latch or buffer. All the stages in the pipeline along with the interface register are controlled by a common clock. Execution in a pipeline process. Execution sequence of the instruction in a pipeline process can be visualized using a space-time diagram. For the example, consider a processor having 4 stages and let there be 2 instructions to be executed. We can visualize the execution sequence through the following space-time diagram. Non-overlapped execution stage cycle. S1 stage, stage 2, stage 3, stage 4, I1, I2, I3. Total time 8 cycle. Overlapped execution stage cycle. Stage 1, stage 2, stage 3, stage 4. Total time equal to 5 cycle pipeline stage. RISC processor has a 5-stage instruction pipeline to execute all the instruction in the RISC instruction set. The following are the 5 stages of the RISC pipeline with their respective operation. Stage 1 instruction phase. In this stage, the CPU reads instructions from the address in the memory whose value is present in the program's count. Stage 2 instruction decode. In this stage, instruction is decoded and the register file is accessed to get the values from the register used in the instruction. Stage 3 instruction execute. In this stage, ARD operations are performed. Stage 4 memory access. In this stage, memory operands are read and written from the memory that is present in the instruction. Stage 5 is a write back. In this stage, computed fetched value is written back to the register present in the instruction. Performance of a pipeline processor. Consider the segment pipeline with the clock cycle time TPS. Let there be n tasks to be completed in the pipeline processor. Now the first instruction is going to take k cycle to come out the pipeline, but the other n1 instruction will take only 1 cycle each. Total n1 cycle. So time taken to execute n instruction is pipeline processor. You want to see the GPU graphical processing unit, then this is the image for you. Compute core, memory access from computer core, execute internal channel, submit command, context, device memory, DMA, host memory, and apps. Now what the GPU stand for? Graphical processing unit. GPU stand for the graphical processing unit. A specializing processor is originally designed to accelerate graphic rendering. GPU can process many pieces of data simultaneously, making them useful for machine learning, video editing, and gaming application. So what are the features of GPU? GPU graphical processing unit accelerate the rendering of real 2D, 3D graphic application. Video editing and creation of video content has improved with the GPU. Video editor and graphic designer, for example, can use the parallel processing for a GPU to make the rendering and high definition video and graphic faster.